Okay, solving systems by substitution. A system is two or more equations. And right now we're going to work with just two equations. We can go to 3 and 4, and they really get complicated. But we're going to know what the x and y are in two equations. And the values for x and y would have to match. So whatever values we find for x and y here would give us the same values. Or should I say it another way? We're trying to find out what values x and y can be that will solve or make both of these equations true at the same time. Okay, so let's work on that. So for substitution, we need a y equals or an isolated variable. So we have one, y equals 2x minus 1. So let's put a little line of demarcation here. And we're going to start with substitution of the y here. So I'm going to write down the 2x plus 3y is 13. And we're going to make a substitution of this y right here for 2x minus 1. So this is going to become 2x plus 3 parentheses 2x minus 1 here equals 13. So there's your substitution. The y became the 2x minus 1. Now we went from two variables, x and y, to just one variable. And now we solve for that one variable x. So using the distributive property with 3, we're going to end up with 2x plus 6y minus 3 equals 13. Here we're going to collect like terms on the same side, the 2x and the 6x. That's going to become 8x minus 3 equals 13. Okay. Now, we continue to isolate for x. We're going to add 3 to both sides and then divide by 8. Again, we're getting rid of the subtracting 3 and the multiplying 8. So let's add 3 to both sides. And we get 8x here becomes equals 16. Now we divide both sides by 8. We end up with x equals 2. Okay, so we found the value for x. To find the value for y, we're going to go back to the y equals 2x minus 1. Y equals 2x minus 1. And we're going to use substitution here for the x. We're going to make that 2. So, and to indicate that I'm using substitution, I'm going to use parentheses. So when you're making substitutions, I want you to use parentheses as well to demonstrate there's a substitution going on. So this becomes 2 times 2 minus 1, which is 4 minus 1. And 4 minus 1 is 3. So we have that x is 2 and y is 3. We're going to write that as a coordinate 2, 3, which again means x is 2 and y is 3. Okay, number 2. We're going to use substitution to solve this, and we see that the x is isolated here, so we're going to use this for substitution. So rewrite 2x plus 4y equals -2. Then below that, the x here, we're going to replace that with a y plus 5. So 2 gives the y plus 5 right there. And then 4y equals -2. So the x has now become the y plus 5. So instead of the equation of x's and y's, it's the equations of all y's. Now we'll distribute the 2, which gives me 2y plus 10 plus 4y equals -2. Okay. Now I'm going to collect my y's together, my 2y and my 4y, and that's going to become a 6y. So we'll have a 10 plus 6y equals -2. Okay. Now I want to get rid of the positive 10 here and then the multiplying 6. So get rid of the positive 10. I'm going to subtract 10 from this side. Subtract 10 from this side. We end up with 6y equals -12. Then let's divide both sides by 6. And then we'll finish isolating y. And we end up with y equals -2. Okay. Now, let's put a line of demarcation here. And now we're going to solve for x. And x here is y plus 5. So x equals y plus 5. And we're going to make a substitution of the y here for the -2. So we're going to indicate that by parentheses here. Plus 5. So a -2 and a 5, they make 3. So we have the value of x is 3. So I will write the coordinate as 3 for x and -2 for y. Okay. Okay, number 3. Number 3, we see that the y is isolated, so we're going to use that for substitution. So, line of demarcation, we have our 2x minus 3y equals -8. And the y, we're going to change that into a 2x plus 4. 2x minus 3. Now we have 2x plus 4 here. Okay, so was x's and y's, now to x's and x's. Let's go ahead and distribute the -3 here and here. That will give us 2x minus 6y minus 12 equals -8. Okay, good. All right, now we're going to collect like terms. We have 2x and -6x. When they collect, that'll become a -4x. Minus 12 equals -8. From here, I'm going to add 12 to both sides. And now I have -4x, it's canceled, equals +4. Okay, from here, I'm going to divide both sides by -4. End up with x equals the -1. All right, so a little demarcation here. Start solving for y. So y is equal to 2x plus 4. And we're going to make a substitution of x for -1, or -1 for x. So y equals 2, parentheses, -1 plus 4. 2 times -1 gives us a -2 plus 4. And then when we combine these, we'll get y equals +2. So we'll write our solution as x is -1 and y is +2. Okay. Here, we have 2 variables that are isolated. The y is isolated here, and the other y is isolated there. I should say. We have 2 isolations. So I'm going to continue to write the first one here, which is y equals -3x minus 8. And then I'm going to substitute this y right here for the 2x plus 7. So this y becomes 2x plus 7. Okay. Now, typically I do show my substitutions by using parentheses. Here, it doesn't hurt if we use them. We're going to try to get the x's to one side. We have right side x's and left side x's. I want this to be a left side problem, so we're going to take all the x's over here. So let's add 3x here, and add 3x there. We end up with 5x's plus 7 equals -8. Now, we get rid of the positive 7 by subtracting 7. Both sides. We end up with 5x equals -15. Divide both sides by 5. And we now have that x is equal to -3. Okay. We can use either equation since we have y equals on both. I'm going to choose the first one because there's a lot of negatives. Just to get us through the negatives. And maybe I'll do it twice. I'll do it twice for both equations just to show that it works fine. So we have y equals -3x minus 8. We also have y equals 2x plus 7. I'm going to substitute the -3. And Anaya, feel it. So we have y equals -3, parentheses, -3 minus 8. All right, so 3 is multiplied, and what we get is a 9 minus 8. And y ends up being 1. Okay, over here, let's do the same thing. Y equals 2, substituting the -3 here, plus 7. So y equals -6 plus 7. And y is 1. So that's our confirmation that x is -3 and y is 1. And that's the solution of this system.